In 1826, English chemist John Walker made a serendipitous discovery that would revolutionize the way we start fires. Walker, who was deeply involved in developing a formula for igniting firearms, was experimenting with a mixture of antimony sulfide, potassium chlorate, gum, and starch, all applied to the end of a wooden stick. His goal was to create percussion caps, tiny explosive devices used to ignite gunpowder. One day, while Walker was drying one of these sticks, he absent-mindedly struck it against his hearth. To his surprise, the stick ignited with a brilliant flare, reminiscent of the bright flash of a match head. This unexpected reaction was due to the chemical combination of potassium chlorate and antimony sulfide, which, when struck, generated enough friction to cause ignition. Interested by this accidental ignition, Walker began refining his formula. By adjusting the chemical proportions and experimenting with different compositions, he improved the reliability of the reaction. In 1826, he started selling his new friction lights to the public. Despite not patenting his invention, an oversight that allowed others to produce similar matches, Walker was the first to create a practical and portable means of starting fires with a simple strike. Walker's invention marked a significant advancement from earlier methods of fire starting, which often relied on cumbersome and dangerous techniques like flint and steel, or using chemical reactions that were less reliable. His friction matches were a game changer for everyday life, providing a safer, more convenient alternative. The invention quickly gained popularity and spread across Europe and America, transforming how people managed fire. Interestingly, Walker's friction matches paved the way for the modern match industry and inspired future innovations in safety and convenience. Now it's time for today's subscriber pick. In the heart of a cutting-edge research lab, a group of scientists embarked on a groundbreaking experiment. They had secured an ancient, untouched coffin, reputed to be thousands of years old. Their purpose is to capture the long-forgotten secrets that lay within. With trembling hands, they placed a small, high-definition camera inside the coffin, eager to unveil the mysteries of the past. As the camera's feed flickered to life, the room fell silent. The screen displayed nothing but darkness at first, the camera slowly adjusting to the dim, suffocating space. Then something moved. A shadow, subtle yet unmistakable. The scientists leaned in, hearts pounding, trying to discern what they were seeing. Suddenly, the shadow took form, revealing a gaunt, skeletal hand, still draped in decaying fabric, reaching towards the camera, as if in response to their intrusion. The hand moved with an unnatural fluidity, sending chills down their spines. Without warning, the screen erupted into static, and a blood-curdling scream pierced the silence. Not from the camera, but from deep within the coffin itself. The scientists recoiled in horror as the sound filled the room, a sound that no living thing should ever make. They tried to cut the feed, but the screen remained fixed on that ghastly, grasping hand. The air grew colder, and an oppressive sense of dread enveloped them. It felt as though the centuries-old coffin had become a gateway, a conduit to something far more sinister than they had ever imagined. In their desperate attempt to uncover the past, the scientists had awakened something that was never meant to be disturbed. The camera went black, but the screams echoed long after the screen had faded, leaving the researchers to question if they had merely captured a ghost or unleashed a curse that would haunt them forever. Could this discovery have consequences far beyond what they could ever imagine? Let us have your opinions in the comment below. Number 5. The world's first venomous frog. Brazilian biologists made an astonishing discovery the hard way. Carlos Jarrett, a seasoned researcher, was exploring the vibrant jungles of southwest Brazil, known for its incredible biodiversity. Amid his expedition, he stumbled upon a frog that appeared to be harmless. With his extensive expertise in the local ecosystem, Carlos believed it to be a benign species and decided to handle it. However, this frog had a surprising and dangerous secret. As Carlos picked up the frog, It suddenly started thrashing and headbutting his hand. This unusual behavior caught Carlos off guard. The real shock came when he and his colleague, Edmund Brody, investigated further. They discovered that this frog, named the greening sprague, possesses a unique and rare defense mechanism. Unlike most amphibians, which secrete toxins through their skin to deter predators, the greening sprague takes a more aggressive approach. This frog is the first known species to actively inject toxins into its attacker's bloodstream. When threatened, it retracts the skin around its upper lip, revealing sharp, bony spines. These spines are not just for display, they serve a crucial purpose. At the base of each spine, there are specialized glands that produce a potent toxic mucus. When the frog is provoked, it uses these spines to forcefully inject the toxic substance into the predator's bloodstream, causing a painful and potentially lethal reaction. The greening sprague's discovery sheds light on the extraordinary adaptations of amphibians and highlights the incredible evolutionary innovations that can arise in nature. Number 4. Discovery of Vaseline. In 1859, a young chemist named Robert Chesebro was deep in his laboratory, driven by the booming oil industry to discover new energy sources. Amidst his experiments, he stumbled upon a curious waxy substance that clung to oil rigs. This peculiar material, known as rod wax, caught his attention because it seemed to have a remarkable ability to speed up the healing of cuts and bruises. Intrigued, Chesebro became determined to uncover the secrets behind this mysterious healing goo. He diligently collected samples of rod wax and spent countless hours experimenting to extract and purify its essential compounds. After numerous trials and errors,